Hi everyone, this is going to be your pre-lab lecture for simple distillation. However, I do want to address some emails that I've been receiving, and it's mostly about your data analysis. Make sure that these questions are very, very well answered, very thorough. They contain details because the data analysis portion of your notebook weighs a lot. It is worth 20 points. So I just want to make sure that you guys understand that a lot of points are coming from here and a lot of deduction can also come from here. So just make sure you answer those questions to the best of your ability and make sure you understand the question to answer it. And that is pretty much it. The simple distillation is for Group B is going to start with it for the week of September 28th through October 2nd, and then Group A will be doing it the following week, which is the week of October 5th through 9th. And Group C follows the same schedule as Group B, so you guys are going to be doing it this upcoming week, which is the September 28th week. Okay. Just a reminder, this lab is completely online, so you guys are going to be working on this from home. All right. This is what your pre-lab page looks like on your Canvas. Make sure you read your lab manual, you watch these two videos, you watch this video that I'm going to post, do your pre-lab notebook, your pre-lab quiz. Remember, every pre-lab quiz is due before every Wednesday at 8 in the morning. This is what your setup would look like. Now, I know you guys are not coming into lab, but it is important to know how to construct or set up your simple distillation apparatus because it can come in handy in other labs. So make sure you guys still know that this is the setup and this is how you would piece everything together. And then you will complete your post-lab notebook, and make sure your complete notebook has your pre-lab and your post-lab together. You guys have to turn both of them together before 11:59 p.m. every Sunday. And this is the data that everybody's going to use. Let me share PowerPoint. Okay, simple distillation. Distillation is a technique that depends on our ability to arrange volatile chemicals into the gas phase. A volatile chemical is just one that easily evaporates. A close evacuated system. This is the first system they talk about in your lab notebook. And basically, it involves the number of molecules in the gas phase, which will initially increase until the rate at which they re-enter the liquid becomes equal at the rate at which they escape from. And at this point, you will not observe a net change, and you can state that there is a state of dynamic equilibrium. The magnitude of vapor pressure at a given temperature is called the equilibrium vapor pressure of the liquid at that temperature. Pressure in a closed system increases as the temperature of the system rises. This is why we should never heat a closed system. If you have so much pressure buildup, the first thing that's going to happen is going to pop, it's going to break, and you don't want that. So rule of thumb, never heat a closed system because of pressure buildup that is caused from rise in temperature. An open system. This is the second system they talk about in your notebook. And basically what happens is molecules of vapor mix with air because it's now open, it's not closed. The total pressure above the liquid is defined by Dalton's law of partial pressure and is equal to the sum of the partial pressures of the sample and of air. I didn't include a equation, but it is equation 4.1 in your lab manual. The partial pressure of sample is equal to the equilibrium vapor pressure at the given temperature. When the temperature of the liquid is raised, I'm sorry for the typo, the equilibrium vapor pressure of the sample will rise, and the number of gas molecules that have escaped from the liquid by the process of evaporation will increase in the space above the liquid. At higher temperature, partial pressure of sample will be a larger percentage of the total pressure. This trend will continue as the temperature of the liquid is further increased until an equilibrium is established where the vapor pressure of the sample equals the total pressure. Okay, this is continuation of the open system. When the temperature of the liquid is such that the equilibrium vapor pressure of the sample equals the total pressure, the rate of evaporation increases dramatically and bubbles form. So if you start noticing this, you're going to notice that this is the boiling process. And at that given temperature associated with the boiling process is going to be your boiling point. The boiling point is dependent upon total pressure. Boiling point of water is 100 degrees Celsius only when the external pressure is 760 torr. Normal boiling point of a liquid measures at 760 torr. What that means is, I'm sorry, I didn't include this graph, so I'm just going to have to show you through here. Can I make this? Okay, no, I can't. This is a chart on your lab notebook, and I realize that it's flipped for you guys, but I'm going to try my best. You have 760 here, and this is where we start measuring. And right here you have 60 degrees Celsius. You put these 2 points together and you find your boiling point. Simple distillation, what we're doing for this lab. The boiling point of a liquid is affected by the presence of both non-volatile and volatile impurities. So simple distillation allows for separation of distillates from less volatile substances that remain as pot residue at the completion of distillation. It allows isolation of the various components of the mixture in acceptable purity if the difference between the boiling points of each pure substance is greater than 40 to 50 degrees Celsius. Later on, we're going to be doing fractional distillation, and this range right here is completely different. So later on, make sure you know how to differentiate between simple and fractional, but for right now, just make sure you know that this is the range you're going to be working with. I know in your lab manual they gave you an example. Diethyl ether with boiling point of 35 and toluene with boiling point of 111. Subtract them and then you can find your range. If it's between the range, you're good, you know? Okay. Non-volatile impurities. Non-volatile impurity reduces the vapor pressure of a pure liquid because it lowers the concentration of the volatile constituent in the liquid phase. The head temperature in the distillation will be the same as for the pure liquid. Pod temperature will be elevated due to the decreased vapor pressure of the solution. Make sure you know the difference between the head temperature and the pod temperature. Super important for you guys to know that. As pure liquid distills, the pod temperature will rise because the concentration of the non-volatile impurity increases, further lowering the vapor pressure of the pure liquid. So like I said, from this slide, main thing you need to know, head temperature and pod temperature, what happens to them, what happens to the pressure between both of them, and that's pretty much what you guys need to know from this slide. I'm so sorry if I mispronounced this, but I believe it's Raoult's law. I looked it up, but I probably still mispronouncing it. And it's the quantitative relationship between vapor pressure and composition of homogeneous liquid mixtures. It involves the mole fraction, which is the fraction of all molecules present in the liquid mixture that are molecules of X. You can find the mole fraction by dividing number of moles divided by the sum of the number of moles of all components. It's strictly applicable to ideal solutions. Now, ideal solutions are those in which the interactions between like molecules are the same as those between unlike molecules. Dalton's law, which is the law that I was explaining earlier, and I believe it was for an open container that I was explaining. When a mixture contains two or more volatile components, the total vapor pressure is equal to the sum of the partial vapor pressures of each component. Fractional distillation later. Like I said, we're going to see fractional distillation later, so don't really worry about that right now. The objectives for this lab: to demonstrate the technique for purification of volatile organic liquids containing a non-volatile impurity, and the purification of cyclohexane. Your notebook. I decided to include this slide because I did not include it in my last YouTube videos, and I know it could have been a little bit confusing. So you want to make sure you have percent recovery, both in your pre-lab calculations and your post-lab calculations. Remember, your post-lab calculations are part of your data. Include simple distillation apparatus setup and procedure. You'll have the setup for this in your procedure. I believe it's below step 6, and it's figure 4.3. So make sure you draw it and you label it, because you will get both quizzed and tested on the setup. changes for your experiment. So this pertains to group C more than anything, because you guys definitely don't come into lab. Well, actually every lab, I'm sorry, because this is an online lab. So make sure everybody adds these changes to their lab. You will grease the joint slightly. Use hexane to remove the grease. Now this grease is used when we are setting up. Let me show you guys. You will grease these joints right here. And then we would use hexane to take off the grease, basically when we're cleaning up already. And do not dispose of boiling stones. Your boiling stones should go in your round bottom flask, and you're not supposed to dispose of them. Make sure data analysis and post-lab questions are well explained. I said this at the beginning of the video, but it is super important that you guys make sure that you are very thorough with your questions. Now, let me show you guys your data, just so you guys don't have any questions about that. Okay, as you can see right here, it says calculate yourself. So you only have to worry about calculating 4% recovery for this lab. And that's pretty much all I have for you guys. If anybody has any questions about this lab, please let me know. Like, you can use this as a resource. You can study this for your quiz, and that is completely fine with me. Just make sure, like I said, include the sample distillation apparatus setup in your notebook and include it either in procedure or in your data, wherever you want to include it. And that is pretty much it. Make sure you answer your post-lab questions. Super important. Answer them. Don't forget about them. And I'll see you guys for acid-base extraction.